So this is lesson 13.5 in intermediate algebra, and we are going to get into a bit of the binomial expansion. We're not going to do very much at all in this. There's just a couple things that I just want to bring up, and it's not stuff that is really useful as far as finding answers to anything, but the reason I want to bring it up is because it will give you just some experience with some different formulas and stuff. That's pretty much the only reason, and we're only going to do a little bit of this. There are different methods of taking a binomial. That's why it's called binomial expansion. And let's say that you have x, let me get my pen working, x plus y to the fifth power. That means that we've got x plus y times x plus y times x plus y, okay, 5 times. And this would take forever to solve because you do the FOIL method here, take that answer, multiply it times that using FOIL method, and then times that, and then, so it just goes on and on and on. It'd probably take you a half hour to do that. But there is a formula, well, there is a picture called Pascal's triangle that is on page, middle of page 772, but there's also a formula to figure out the answer there, and we're not going to figure out the answer because it just takes a lot of time and a lot of formulas, and it's the end of the year and you're just kind of like done. So I'm just going to show you just some little bits and pieces of some things that will help you in math down the road. The first one is called factorial notation. Alright, so if we have a number, like, let's just choose 5, this exclamation point is called a factorial notation. And what that means, it's just a symbol that means take 5 times all of the numbers down to 1. So 5 factorial would be 5 times 4 is 20, times 3 is 60, times 2 is 120. If I took 8 factorial, that means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And your calculator actually has a button that looks like that. And if you punch in the number 5 and then hit this that symbol there, it will give you 120. Okay, so it's kind of a nice button to have, and so you'll be making some use of that. So one of the things I want to do is just give you a formula, just because I want you to practice it, and it's called the formula for the binomial coefficient. And it looks like this. I don't want to put a line there. There's no line there. NR, and we put that in parentheses. And that equals n factorial all over r factorial times n minus r factorial. So what that means is this n minus r, you do the n minus r first, and then you push the factorial key on your calculator. Alright, so that's the formula. So if it asks you to calculate the binomial coefficients, this is a binomial coefficient right here. And this is the first part of solving, where you have like an x plus y, and it's in parentheses, and it's to the 10th power or something. Some crazy thing that you don't want to figure out. This is the first step. So if you had something like x plus y to the 10th power, this would be one of the first steps in order to solve that. So again, we're not going to do that whole thing. We're just going to do just some bits and pieces to kind of get your feet wet. Alright, so calculate the following binomial coefficients, example 1. So we have, they give us 7, 5. Oops, gosh, I keep putting an under, or I keep making it into a fraction. Okay, so they want us to find the binomial coefficient. Alright, so if we use this formula that we have right there, we're going to take n, which is the top number, factorial, over r factorial times n minus r factorial. Alright, so what this looks like then is 7 factorial over 5 factorial times 7 minus 5 is 2 factorial. Okay? So what you're going to do, well, there's really a couple ways of doing this. If you want to do it by hand, which I'll show you how to do first, you can do that. As far as your calculator is concerned, you put 7 factorial, put that number up here. 5 factorial, put that number down here. 2 factorial, which is just 2, put that number here. And then multiply the bottom 2, and then, do your division. But if you were to want to write it out, you'd have 7. Let me show you how easy this is. Okay, so you've got both of those. All right, then you cancel. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that gives me 42, 7 times 6 over 2, which is 21. See, so it's real easy to just do it in your head or do it on paper like that, because you can cross out, you can cancel most of the factorials like that, and it just makes it real easy. All right, so let's do the second one. And again, we're not going to go any further than this. Let's leave that one up there. So we have 6 and 2. So 6 goes on top, 2 goes on bottom, 6 minus 2, and that gives me 6 times 5 times 4 times 3 times 2 times 1 all over 2 times 1. And this is 6 minus 2 is 4. It just tells you where to start. Okay, 1, 2, 3, 4, 1, 2, 3, 4. So I have 30 over 2 equals 15. So 30 over 2 equals 15. Okay. One more, just because these are so much fun. 3, 0. Whoops, gosh. That equals 3 times 2 times 1 over 0. Okay, so 0 doesn't get anything, but let's write it as 0 factorial times n minus r. 3 minus 0 factorial. Alright, so what do we get here? 3 times 2 times 1 over 0 factorial. And one of the things about factorials is when you have 0 factorial, that always equals 1. Okay, I know, really, really weird, but that's the way it's going to be. So 3 minus 0 is 3 factorial. Cancels that, cancels that. And even though everything is gone there, there's still always an assumed 1 up there. You can never just get rid of that and have it go away. It's going to be a 1. So your answer to this is 1 over 1, or 1 for an answer. Okay, so that's a key thing. 0 factorial is the number 1. And let's see, then they get into binomial expansion formulas and do a bunch of other stuff in here, but we're just not going to do that. We'll save that for another time. So as far as your homework is concerned, ignore what's on the website if it hasn't been changed. And let's see, which ones do I want you to do? Actually, surprise, surprise, there are none that I want you to do. As far as the actual homework assignment is concerned, what I would like you to do is, if you look over on page 777, where it says extending the concept 65 to 68, what I would like you to do is, and let me get rid of all this. So like 65, it gives you 8, 5. What I'd like you to do with that 8, 5 is use this formula. 8, 5, 8 minus 5, and go ahead and solve that. Okay? And do the same with the 8, 3. And then 66, it gives you 10, 8 and 10, 2. And then 67, 20, 12 and 28. in 68, 1510, and 15.5. So don't even pay any attention to what the instructions say. Just do the what is called, again, clear back example 1, calculate the following binomial coefficients. So just do what we just did on 65 through 68, and that will be it. So there's 1, 2, 3, 4, 5, 6, 7, 8 of these to do, and we'll call that good. Okay, thanks. That's it for 13.5 in the entire book.